So, and then generation of molecule mixture candidate. Okay. This is last class I think, but we don't have the class on the Thursday, so sorry. Okay. So generation of the molecule structure based on the constraints given. Okay. Such as if you want a structure that have a 2CH3, 2CH2 as well as 1OH. So we discussed already that one, as well as we see the molecule which is chemically feasible based on the Odell and Macchiato rules. Okay, so that's once you already did it from by from the activity. Okay, so for this part, okay, for this part we move to the property prediction. Okay, this is how to predict the properties, which is we don't have the data from the experimental or non-information. Okay, and we need to predict by using the property models. Okay, so for today I think we just focus on the property predictions. Okay, some part from the property predictions. Okay, and maybe not on the CMD problem formulations. Okay, so how can we predict? Okay, this by using the computer, but this is just general. Okay, what is the step to predict the properties? Okay, based on the hierarchy or based on how many steps that we have to follow actually. Okay, so property predictions. Okay, for the molecular design or CMBD goes on the molecule and blend design. Okay, usually the target properties include pure compounds, okay, as well as mixture properties. Okay, so there are two main type properties, either singles or mixture. This is we discussed previously. Okay, I think from our first part. Okay, so in order to predict the properties, of course, you need a library. Okay, so you need a library. Okay, okay. So the selection of properties models, there's some issues that arise due to the prediction of the model. Okay, for example, is the application range of the selected models. This one. Okay, and as well as availability of the model parameter. Okay, maybe the software or they have a certain building block. Okay, but some parameters is not available, as well as uncertainties. Okay, so uncertainties in their properties estimation. Okay, so this one is maybe some parameters are not good, and some prediction maybe lead to some error. This is what we call is uncertainty, or maybe the range is too big. Okay, so that is we lead to the uncertainty. Okay. So for the application range, actually is we limit the size of the search space. Okay, for the CMD or CMBD problems. Okay, such as size of the searching size space. Okay, and the less opportunity to find the target compounds. Okay, so the large is gonna be large to find the target compounds. Okay, and when the properties or parameters not available, okay, to estimate the target properties to generated molecules or the mixture. So actually we cannot predict. So this one we have to eliminate or remove from the list potential candidate. So if some parameters is not available, so we have to eliminate this one. Okay. And also we have to eliminate the potential optimal products. Okay, this is what is the constraints if the parameters is not available. Okay, so from that the estimation model will be a fewer parameters, and it's going to be large application range. Okay, so for example we disassemble to the smaller fragment. Okay, and the parameters is going to be okay, for example CH3 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 CH2, so we disassemble into small fragment, right? Okay, so the parameters would be more. So the searching is going to be more. Okay. And if you arrange in terms of the functional groups, it's going to be larger possibilities. Okay, many more different structures. Okay, but you have to differentiate the axon. Okay, so that is the target and the selection properties. Okay, so based on the estimation task, okay, there's a step that you need to go through for the prediction of the properties. Okay, which we arrange hierarchically and based on the computational effort and as well as cost. Okay, so this is the examples. They have a four hierarchy. Okay, one primary, secondary, okay, third functionals, as well as fourth is the mixture. So you have to follow this hierarchy. Okay, and for each hierarchy they have a property type. Okay, primary, secondary, functional, and mixture. And then a property. Okay, on the third column, and the last column is the calculation method. Okay, so we have to follow this hierarchy. Okay, so generally we have to start with the primary. Okay, for examples, you have 1,000 candidates to determine the target compound, which is a liquid in the what is it in the room temperature. So the primary properties, the target properties is you choose a normal boiling point as well as a normal melting point with the certain constraint. Okay, what is the materials or compound that have which is the phase is liquid at the room temperature, right? So you calculate and then you can reduce the number of the target compounds from 1,000 to 500. Okay, and then you move to the second hierarchy or second step. Okay, okay, and then from the second step, which is property type, is the secondary. So you reduce more. Okay, for example, you choose the eccentric factor to calculate all the properties by using the computer. Okay, and then you can reduce to 250. Okay, you do the screening. Okay, from 1,000 to 500, and then 500 you can reduce to 250, and then you go to third step, which is functional. And then your target is maybe vapor pressure density. Okay, what is the vapor pressure what within certain range? Okay, and diffusion coefficient. Okay, thermal conductivity within certain range. And then you can reduce the numbers of properties to 100. Okay, and then you move to the next step, which is a mixture. Okay, or which is a step 4. Okay, so you can reduce until 50, and then you do the calculations by using software and target properties, or do experiment. Okay, verify by using experiment for the 50 target compound or possible compound, so that you can verify your target compound. Okay, so consequent and subsequently, okay, so you can calculate by using a computation for the candidate which is satisfied all the target using simple models. Only for those candidate that has satisfied all the target by using simple property models. Okay, so if all are satisfied, so you can calculate and then verify by using computer. Okay, by using simple. Okay. So this is the classification of the properties. Okay. So properties from the hierarchy. Okay. This one. Okay. From the previous, you look at here. Primary, secondary, functional, as well as mixture. Okay. So for the primary, if you look at here, the single value properties calculated using structural information only. Okay. Which is the structure we disassemble into the BCH3, CH2. Okay, that is a primary. Okay, and then secondary, in addition to structural information, usually a function of other properties. Usually is depend on the the primary. Okay, we depend on the primary. Okay, of course it's going to be redundant with the primary. Okay, because we need information from the primary. Okay, and then functional. Okay, pure compound properties that depend on the intensive variable temperature as well as the pressure. Okay, so this is the second step as well as third step, and then the mixture. Okay, this is another additional structure information. Okay, so it's depend on the variable, other variables such as temperature, pressure, and also composition. Just similar like functional properties. Okay. So for the polymer actually is also similar. Okay, this one is maybe like yeah, the classification of the properties also similar for the polymer repeating in it. Okay, primary, secondary as well as functional properties. Okay, so this is the relationship. Okay, among the properties models. Okay, this one, and then as well as the properties. Okay, solver, okay, as well as the calculation algorithm. Okay, so for example, this one, if we select the property, okay, we need the information from the property models. Okay, so you have to calculate by using MG. Okay, this one is Marie-Rogani, okay, model SRK Unifact. Okay, so if you want to estimate the properties, so we need this property models. Okay, you have to select this one. Either you want to Unifact, PS stuff. Okay. However, for the phase equilibriums or the like a VLE, okay, vapor liquid equilibrium, liquid liquid equilibrium as well as solid liquid equilibrium. So we need the mixture properties, which is a solution algorithm. Okay, from the numerical solver. Okay, I think VLE you already learned in from the what is it, from the chemical and engineering thermodynamics. Okay, what is a VLE? Okay, so you need the numerical solver like the nonlinear equations, right? So to estimate the other properties. Okay, and you need the numerical solver. This numerical solver also untuk for the face behavior. Okay, so this one is important. Okay, so you have to calculate uh, in order or according to the hierarchy. Hierarchy 1, 2, 3 as well as S4. Okay, so that is the about the hierarchy in for the prediction of the properties model. Okay, so you have to remember there is four hierarchy. Okay, primary, the property is primary, secondary, functional as well as mixture. Okay, okay, so let's see the models for the primary properties. Okay, the primary model properties is structural variables. Okay, depending on the structure. Okay, because it's only function of the pure components, pure compound of the molecular structure. Okay, this is for the primary properties. Okay, so the group contributions is based on the Mario-Gani method. Okay, and G method. Okay, if I just remember I upload the three papers in the e-learnings. You have to read all those paper, and then you have to use all the information in those paper for to do the activity. Later I will show you the activity. Okay, and you have to submit because all the information is available in the paper, all three papers. Okay, so group contribution approach based on the Marugani is a simple, accurate, and as well as they have a extensive group parameter tables for broad arrays of properties as well as molecules. Okay, so the properties predictions actually in the form this one. Okay, on the left side and the right side, F theta. Okay, and ICI plus MJDJ plus EKOK. Okay, so what is it about this this equation? Okay, so this is the function of the properties of theta. Okay, if you look at here that CI is the contribution of the first order group. Okay, of type I that has an I occurrence. Okay, I is for example just like yeah, we already told you I is something like the function, not function, CH3, okay, the group, okay, how many CH3, Ni is how many CH3 in this group, okay, Ni occurrence or Mj is the occurrence, how many CH2 in this group, okay. J is the, what is it, the type of the group available in the compound, okay. Mj occurrence is the a vector or the numbers of CH2 or CH3 or OH, okay, in the molecule, okay. So this is sum of NiCi, sum of MiDj, MjDj, EKO, okay, same. So this is a first group, a second group, as well as third group, okay. For example, if you have a linear or monofunction of the molecule like CH3OH, okay, it is you can use only until this equation until first order group, okay. But it's not necessary you want to use until second order or third order. It's like a Taylor series. The longer your equation is become more accurate, if you remember, okay. The shorter is become more not really accurate, but for the simple equation, okay, only applicable for the first order, okay. This is what we call it first order. If you combine this one is second order, if you combine this one is third order, okay. Okay, so if CH3OH is just enough if you want to use first order group, okay. And if polyfunctional something like this one, right, is polyfunctional, this one polyfunctional, okay. So you need this second order as well as the third order group. So how many, maybe this one is OH, okay, this one OHH, okay, how many OH, okay, for third order group, okay. And this one CD and CDNE, okay. This one is you can get from the tables in the journal, which is I uploaded in the e-learning. So you have to find it, okay. So you can get this one, the value of the CD as well as E, okay. So please refer to the journal. For the activity, of course, you have to refer to this journal. Just substitute into this equation, okay. Okay. So this is the example of the list of the primary properties. Okay, just now we already explained what is the definition on the right side, right? Okay, on the right side. But how about the left side? Okay, the primary properties f theta. Okay, so look at here. This is the f theta on the left hand side. Okay, in this equation. Okay, so for example, if you want to calculate the normal boiling point, okay, so you have to substitute this equation into f theta, okay. So this f theta will become, okay, exponent, okay, pb divided by t, okay. This is what you have to substitute, okay. So this is the equation that we interested on the left side, okay. This is all the left side, okay. Okay, so tb naught you can refer to here, and tm naught also here. This is the constant. Tm is a melting temperature, Tb is a boiling temperature for that particular temperature, for that particular compound. Okay. 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 So for the step to use the primary properties models, okay, what you have to do is identify functional group. First, you have to identify the functional group. For example, first order first, okay, and then if necessary second and third order group, okay. What you have to do is, if if enough to use the first order, just use the first order like a simple linear structure, okay. You just use first. If a polyfunctional or complicated, you can use second and third, okay. And then you have to determine how many group of each type are needed to represent molecule. This one is, for example, CH3. How many group they will have? Okay, the molecule. CH2, how many group they have? benzene ring, how many they have. Okay, and then retrieve parameters from the model parameter table for properties of interest, as well as sum the contribution and the use corresponding properties model function. Okay, this is a fourth step. Okay, so let's see the examples. This one. Okay, for the normal boiling point, estimate the normal boiling point of butanoic acid diisopropionate ester. Okay, this one is the actually is uh, uh, the structure. Okay, CCOC. Okay, double bond O. Actually, this one is from the SMILES data. SMILES data is from the you can search in the website. Okay, SMILE SMILES for the butanoic acid or isopropyl ester. Okay, so that they have the code also, and also SMILE structure. Okay, for the isopropyl butanoic acid. And then by using the MG method and group contribution parameters, okay, so you have to estimate the normal boiling point. So if you look at here, okay, if you look at here, the solution is we have to identify functional group, which is first order first. If necessary, second and third order group. So if you look at here, okay, for the CH3 1, okay, 2. This one is for CH3. They have two occurrence. Okay, occurrence Ni just now. Okay, occurrence of for the example, if you remember F theta. Okay, so they have a two CH3. How about CH2? So if CH2 1, 2, 3, this one is it CH2? 1, 2. How many? This one is C. I think CH2 they have a 4. 1, 1, 2, 3, 4, 5, 6. Is it 6? Okay. 6. Yeah, it's a 6. And then CH3CO. COO. CH3COO. Oh, this one is combined. CH3COO. Okay. CH, they have a 2. Okay. So it should be 4 for CH2. Okay. Not 6. CH2 is 4. This one. 1, 2, 3, 4. Because we have this another functional group. CH3COO. This is a primary. Okay. Okay. So sorry. Okay. And then maybe we have a secondary, second order group. Is it possible? If second order, I think second order OO. Is it OO? Is it OOC? This one second order possible. And then CH2, CH2CO. This one can be second order. Okay. Okay, I think it's already enough. No need to the third order. Okay, I think we can calculate this one. Okay. So however you can try first order first, and then you can compare with the second order calculation. Is it the error is uh, not so much different? If not so much different, I think you can just use the first order. It's enough. Okay. So let's recheck. Okay. Let's recheck. Okay. So look at here, yeah. First order we have two. Okay, CH3 4, and then CH3CO. Okay. And second order 1. Okay. And third order is not necessary. So to calculate the normal boiling point, okay, just substitute to the first primary properties models together. This one in on the right side, right? If you remember the left side, if you remember for the normal boiling point, okay, this one, okay. So you use this equation, okay, this equation, okay. So and then for the for the right side, okay, number of occurrence, okay, we have now we know already the number of occurrence, okay. Cm, okay, Ci, right? Number of occurrence is how about the number of occurrence? What the symbol just now? Oh, this one. So number of occurrence and IMG as well as OK. Okay, this one and OK. Okay, so this one. So MK, this one, and okay, M as well as um, and M as well as OK. Okay, okay. So from the experimental value, actually we can get 5 to 3, but from our calculation, if you look at here, okay, so we can get 5 to 8.23, almost close. Okay, from the prediction, okay, from the experimental volume value. Okay, see. So that means if you have many targets compounds, isn't it? So you don't need, for example, you have 2000, you don't need to use you don't have to do an experiment for 1000 target compound. Okay, because there are many possible. You can arrange this group. Okay, any compound actually. Okay, so you can reduce based on the hierarchy 1, 2, 3, and as well as 4, so that you can reduce the number of experiment that you have to conduct it. So after this primary hierarchy, primary properties, okay, so you can move to the next step, which is secondary model, secondary properties models. Okay, so you can reduce another more properties. Okay, another target compound. Okay, so that is for the primary. Okay, so for the polymer repeating unit, okay, similarly also, okay, for the primary properties of the polymer repeating units, okay, GC based methods, okay, for such as Van Craven and MG method adapted for the polymer that can be used. This one also you have to refer to the journal that I provide in the links. Okay, so Van Craven's, okay, this is the equations, left side and the right side, okay. They're almost similar like previous equation. Okay, just change left side and the right side. Okay, so and then you substitute. Okay, all the informations uh, given. Okay, so look at here. This is the yi. Okay, replacing yi with vi or hi uh, in the equation here. This equation molar volume and the water absorbed. Okay, so you can substitute all this one. Okay, so you can get the answer. Okay, so using the MG method based on base models, okay, so we can predict about 32 Kelvin. Okay, so this is the glass transition model, so we can predict, okay, other than you use experiment. Okay, any question about the primary properties prediction? Okay,
Doctor,
yeah,
Doctor, I wish to know how to get the contribution
how to get
values, the contribution values from the
contribution value.
previous, yes, from the
This one,
previous table you showed.
this one, oh, this one.
Yes. Mm, after that, yes.
This one is a contribution, okay. I think this one is generated, okay, the contribution, okay, from the software. Okay, this one. I will confirm later how to get this one. Okay. Because the contribution I think is not really we can put in the in the in the equation. Okay, only how many contribution of that group in the molecule. Okay. Maybe you have to check in the journals how to get the contribution that are already uploaded in the Okay. But I
Okay.
think this one is not necessary. You have to put in the what is it, in the equation. Okay. The important thing is this one. The what is it, the symbol ND as well as E. Okay. This one you have to get. This is as how many contribution of CH3 in this molecule. Okay. Okay. So the important thing this one. Okay. And MSO is a occurrence. Okay. And then E, M, and C you have to refer to the journal. Because in the textbooks they never provide the 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 what is it, the value for CID as well as E. Okay, so we have to find the journal. So that means this book actually is not the standalone books. This chapter actually is not a standalone. So we have to refer to some to his journals. Okay, Ghani, the author is Ghani, Mariro Ghani. Okay, so I
Okay.
already provide in the e-learning, so you have to read that one. Okay, in order you have to do this what is it, this activity. Okay, so you have to refer to that paper, Mariro Ghani 2021 paper. Okay, so you have to refer that one.
Okay.
Okay,
Okay.
okay,
Thank you.
okay. So I think that's for today actually. Uh, this is what I received from the Dr. Azizul. Okay, what I should cover until the primary. Okay, and then next we're gonna go to because he said we have to understand this primary first before we move to the secondary. Okay, this one also has a secondary. Okay, as well as the model functional properties. Okay, and then after you master that ones, we can move to this one. Okay, and mathematical. This one more equation. Okay, any question? So you have a times. Okay, please read that paper, and then you do the activity. This activity from activity 6 with your group members and submit in the e-learning. Okay, I hope you can understand. What's the activity? Yes, this one. Okay, any question? Okay, please download. Okay,
Doctor,
yeah.
where we can get the second order group?
Where can we get which one?
Uh, for the previous slide.
This one.
Okay, this one. That one. Second order group.
Second order group. This one. This one.
No,
Combination.
no, no. Okay. Yeah, that one.
Ah, kenapa?
If can have a list or what? Same like first group, first order group.
Uh, yeah, it's almost similar. It's going to be redundant actually. It doesn't matter. So that means you try first calculate by using first order, right? And then you try by using a second order. Is it the answer is almost similar or just what is it? The answer is close or they have a many difference. If there's many difference, that means you need need the second order. Second order equation. So you need to calculate until this one.
Oh,
Until this one. Okay. You can try. Okay. Is it any different or not? Okay. You can try to
okay.
calculate until here or just here. Okay. So you can compare. Right. So of course it's going to be redundant. Okay. Some properties you have to some properties from the second order you have to take from the first order, right? Okay. But I think for that compound is just enough for the first order is enough. Mm. And then you can move to the second order. Not first order, sorry. First step, primary step. For the primary step is enough for this one. For this example is enough for the first order. Okay. Okay. So I'm not sure. Okay, I'm not sure is if the answer is too much different for the first order group, then the second order group. Okay, so that means you have to choose your equation until the second order group. Okay, so this is more accurate, like a Taylor series. Okay, so that is much better. Okay. So for this activity, 2-ethyl pentanoic acid. Okay, normal boiling point, normal melting point, and heat of fusion. Okay, so please do this one and refer to the journals given in your e-learning. So for the other symbols, okay, and as well as this one is F theta, right? F theta just a normal boiling point, normal melting point. You just take from here on the left side of the equation. On the right side, okay, you can refer to the journals, the value. Okay. Okay. Any questions? I think that's all for today, I think.
Doctor, so
Yeah.
when do we have to submit this activity?
Before next class.
Okay.
Okay, no need to I think it's no need to rush it. Okay, because we also want to move to second and also to third hierarchy. Okay. No need to rush it. You can, yeah, I think you can do, I think. Because today is my, I have also to submit my yearly evaluation for my performance. This is the deadline. But yeah, actually for the yeah, the toilet said okay here for this part. Okay. Okay, any questions before we start? Attendance. Okay. Okay, attendance. Okay, that's all for today. So I share the attendance.
Thank you, doctor.
Thank you,
Please do.
Doctor.
Maybe
Thank
you
you,
have
doctor.
1 hour. Please do that activity, and if you have you already complete, you can submit by today. Okay, just refer to the journal. Read that journal.
Okay, doctor.
Okay,
you, doctor.
doctor.
Okay.
Betul, doktor.
Ya. Apa dia?
Tadi just now I asked about the second order functional group.
Hmm.
Not